Bismillah ar-Rahman ar-Rahim. I will start 9.6, where we have two tests, ratio and root tests. What is the ratio test? It says that you have a series with non-zero terms, okay? Then you'll find this quantity. You'll find L, which is limit n goes to infinity, an plus 1 over an. If that L is less than 1, then we say the series converges absolutely. If L, this is L, greater than 1 or is equal to infinity, then we say the series diverges. F, so you have three cases. L less than 1, converges absolutely. L greater than 1, converges conditionally, diverges. Or L equal infinity, L equal 1, test fails. Cannot conclude anything. You need to think about other tests. Look at this one, 1 over n and 1 over n square. I know this diverge and I know this converge. If you find the limit as n goes to infinity of an plus 1 over an, if you get L, you will get 1. So that means if I get 1, nothing. We cannot conclude anything. It's usually useful, this test is usually useful for series that converge quickly or rapidly, which is usually series involving factorials or exponential. Factorials or exponential, or powers. Okay. Let me just remind you, we did this in section 9.1, where we have these some of the common limits. Since now we are back to the limits. Yeah, I think we'll use some of them, especially this one, especially for the next test, and this one also for the root test. So some of these limits we need. Okay. Determine the convergence of this. What I will do, I'll find L, which is limit. Now, before that, let me, since it's the first one, let me do it in details. What is an? An 2 to the power n over n factorial. What is an plus 1? That will be 2 to the power n plus 1. I change each n to n plus 1. Okay. What is an plus 1 over an? Yeah, that will be 2 to the power. Since it's the first one, I'm doing it in details. Over 2 to the power n over n factorial. In other words, it's 2 to the power n plus 1 over n plus 1 factorial times the reciprocal of this, which is n factorial over 2 to the power n. Yeah. You notice this with this, you're getting 2. This one is what? N plus 1. N plus 1 factorial. Actually, it's what? 1 times 2. And what is this? This is n factorial. So it's n factorial times n plus 1. So this with this, give me 2 over n plus 1. Okay. So what is my L? L will be limit n goes to infinity, an plus 1 over an, and that will be limit n goes to infinity of what? 2 over n plus 1. What is this limit over infinity? Which is 0, less than 1. So what the theorem is saying? If you have this, then the series converges absolutely. Then that means this series converges absolutely. This will find L, then we'll decide. Let me do these two tests. Okay. Now this is AN. AN is what? N square. 2 to the power n plus 1 over 3 to the power n. So let me find L right away. Limit n goes to infinity. AN plus 1 over AN. That will be limit n goes to infinity. I don't need the absolute value since everything is positive. I have n plus 1 square times 2 to the power n plus 1 over 3 2 to the power n plus 1 plus 1. N plus 1 plus 1 over 3 to the power n plus 1 times the reciprocal of n, which is 3 to the power n over 2 to the power n over n square times 2 to the power n plus 1. Yeah. That will be limit. N goes to infinity of what? Yeah. 2 to the power n plus 2 with 2 to the power n plus 1. That give me 2. 3 to the power n. And 3 to the power n plus. Yeah. Let me do it in steps. 2 to the power n plus 2 over 2 to the power n plus 1. They have. Yeah, let me do it in too much steps. Okay. N plus 1 square over n square. 2 to the power n plus 2 over 2 to the power n plus 1. 3 to the power n over 3 to the power n plus 1. Until now, I'm not applying the limit, just I'm trying to simplify the expression. That will be limit. N goes to infinity of what? Yeah. You have n plus 1, which is n square plus 2n plus 1 over n square times, what is this, 2? Here I have 2 over 1, which is 2. Here I have 1 over 3 over 3. So this limit will be what? Same degree. So you have 2 over 3. So this series converges. Absolutely. Part B. What is it? What is AN? AN, n to the power n over n factorial. So we'll find L. L will be the limit. N goes to infinity of AN plus 1 over AN. That will be the limit as n goes to infinity. Yeah, be careful here. Do you need the absolute value? No, everything is positive. No need for the absolute value. Okay. That will be n plus 1 to the power n plus 1 over n plus 1 factorial times reciprocal of this n factorial over n to the power n. I need to find the limit of this. Yeah, be careful with the calculation. Yeah, you should notice that I will write n plus 1 to the power n plus 1 as n plus 1 to the power n times n plus 1 over, what about these two? This with this. We did it before. Yeah. So it will be n plus 1 here. Okay. Times 1 over n to the power n. So this is cancelled. So you have limit n goes to infinity, n plus 1 over n all to the power n. In other words, this is limit n goes to infinity 1 plus 1 over n all to the power n. If you notice, this is similar to this exactly, where my x is 1. So this will be e greater than 1. That means what? This series diverges since L is greater than 1. Okay, now let me do this one. What is an? An is square root of n minus 1 to the power n square root of n over n plus 1. Okay, now let me find L. L will be limit. N goes to infinity, absolute value an plus 1 over an. Since I'm using the absolute value, I will not care about the minus sign. That will be limit. N goes to infinity of what? Yeah, I get rid of this minus sign. So I have about the square root n plus 1 over n plus 2 times reciprocal of this n plus 1 over square root of n. So I need to find this limit. Yeah, if we think about this limit, that will be limit n goes to infinity, n plus 1 over n plus 2. I know this is 1 times square root n plus 1 over square root of n. Also, this is 1. Maybe I need a little bit of manipulation to make it very clear. If I took square root of n common factor, what is the remaining? 1 plus 1 over n inside over square root of n. Yeah. So I have what? This is 1, same degree. This is cancelled. And this is 1. So that is 1. So what will happen? This fails. Can I conclude anything? No, you cannot conclude anything. So what I will do, I need to think about another test. Yeah. I need to think about something else. Okay. Yeah. Now, I think about alternating series. Yeah, now we'll go back to this. Using alternating series test. I need to show what? First, okay. So take this, call it Bn. Okay. It's positive. Okay. So I need to check the limit of Bn as n goes to infinity. It will be, yeah, it's clearly 0. Or let me do it in detail. Limit n goes to infinity. And that I can rewrite it as limit n goes to infinity of what if I divide by n in the numerator and denominator. So I have a square root of n over 1 plus 1 over n. So I have what? Limit as n goes to infinity 1 over square root of n over 1 plus 1 over n. And that give me what? 0 over 1 plus 0, which is 0. So the first condition satisfied. Now, this is part A. Part B, I need to check that it's decreasing. So let me take f of x, square root of x over x plus 1. To check that it's decreasing. So I need to find f prime. What will be f prime? It will be 1 over 2 root x times x plus 1 minus root x times 1 over x plus 1 square. And that, if I simplify it, it will be what? Let me make 2 square root of x there, so multiply by 2 square root, that will be x plus 1 minus 2x. That will be 1 minus x, and this expression negative for x greater than or equal to 1. So the function is decreasing. Okay. Yeah, I'm gonna create. I need more space. So that means what? This series converges by alternating series test. Now I need to check the. Now take, yeah, Pn absolute value of An. Let me call this Cn, not Pn. It's okay. Let me call it Cn here. I call this Cn. Who cares? Which is square root of n over n plus 1. So I need to check this series. Okay. What you will do? Yeah, I can compare it. I will take the n as 1 over square root of n. Yeah, the powers. Into the power half. Yeah. And do the limit comparison test. Do the limit comparison test. Okay. So you have the limit as n goes to infinity of Cn over dn. That will be limit n goes to infinity square root of n over n plus 1 times square root of n over 1. That will be limit n goes to infinity n over n plus 1, which is 1 positive. So either both converge or both diverge. But since Tn, which is this, since you know this series diverges, which is B series, and B equal half less than 1, then this series diverges. Diverges. And that means this series converges conditionally. Yeah. The most important, if I'm getting L equal to 1, that means what? Test fails. We cannot do anything. We need to think about other tests. Okay. Now let me do more problems. Okay. Yeah. So it is my An is n cubed over 3 to the power n with a minus sign. Yeah, the minus sign will make no change. So we need to find L, is the limit. Yeah, that minus sign will make no difference. Let me do it with the minus. N plus 1 cubed over 3 to the power n plus 1. Reciprocal of this. That will be limit n goes to infinity of what? Yeah, this is minus 1. I have over 3, which is limit 1 over 3 times, what is this? N cubed. Same degree. So the answer is 1 over 3. This is the one. So this series converges absolutely. Okay, another one. And it will be L. Yeah, that will make the calculation what? It will be what we are concerned about this and this. That give me what? That give me, forget about the minus sign, absolute value. Yeah, this is gone with the absolute value. So I have n plus 1, because this is what? N plus 1 times n factorial. So this is cancelled. So I have n plus 1 over 3. What is the limit of this? Infinity. So series diverges. I think very clear. This one, we'll find L. I think it's similar to this one, yeah, somehow. Square root of n over 1 plus n square. So an, what is the L? Limit n goes to infinity, n plus 1 over an. And that will be limit n goes to infinity. Be careful here. Square root n plus 1 over 1 plus n plus 1 square. Spherical of this. That will be the limit as n goes to infinity of what? Score everything is positive times yeah. I think we did this before. It's 1 times 1, so 1. So test fails. What I would do, you can do a limit comparison test. Yeah, since the powers from the powers very clear. Take Vn. That's what 1. Yeah, 1 over n to the power 3 over 2. Yeah. Note this series converges. B series. Now, note the limit as n goes to infinity. I'm doing limit conversion test, LCT. And this is the test. An over Bn. That will be what? Limit n goes to infinity of what? It is An. Spherical of this. That'll give me limit. N square which is 1 positive. So this series converges by LCT. It has no relation with the ratio test. The ratio test fails. Okay, so this is my AN. Yeah, be careful here. Okay, now let me do AN plus 1. That will be what? That will be minus 1. Yeah, this is nothing. Times what? This is 1. I need the next term. What is after 2n minus 1? It is 2n plus 1 minus 1. And the same thing here, 2 instead of n, I'll write n plus 1. So that will be, I'm doing it in details, minus 1 to the power n plus 1. Here I have 1, 3, 5, 7, 2n minus 1 times what? 2n plus 2 minus 1, which is plus 1 over 2n plus 1 factorial. Okay. So now I need to do L. What will be L? L, it will be limit n goes to infinity of what? No need for the absolute. This will be gone with the absolute value. So 1 times 3 times 5. That will be an plus 1 over an. Everything is positive. Limit n goes to infinity. 1, 3, 5, 7, 2n minus 1, 2n plus 1. Over what? Over over 2n plus 1 factorial. What is 2n plus 1 factorial? 2n plus 1 factorial, it will be 1 that over 2n plus 1 factorial times the reciprocal of this, which is 2n minus 1 factorial over 1 times 3 times 5 times 7 until I reach 2n minus 1. Let me take another page just to make it all clear. Okay. So let me write L again. Yeah, L will be limit n goes to infinity. The first one, 1 times 3 times 5 times 7. I'm doing it in details. Huh? Times 2n minus 1, 2n plus 1 over 2n plus 1 factor times. Yeah, times the reciprocal of this, 2n minus 1 factorial over 1 times 3 times 5 until you reach 2n minus 1. Okay. Now I need to be careful. This cancelled with this. Yeah. So what is the remaining? That will be limit n goes to infinity 2n plus 1 times 2n minus 1 factorial over. What is 2n plus 1 factorial? If I notice 2n plus 1 factorial, it's 1, 2, 3, until I reach 2n minus 1, 2n plus 1. What is this? This is 2n minus 1 factorial. So this one, I can rewrite it as 2n minus 1 factorial times 2n times 2n plus 1. Yeah. Which means this cancelled. I'm getting what? Limit n goes to infinity 2n plus 1 over 2n times 2n plus 1. This is degree 1, this is degree 2. So this limit equal what? 0. Less than 1. So that means this series, which is minus 1 to the power n, to n minus 1 factorial, converges. Yeah. Let me do more examples. Yeah. I have this to the power n plus 5. I need to check this limit. Yeah. an is what? 2 to the power n plus 5 over 3 to the power n. So it will be L. It will be limit n goes to infinity an plus 1 over an. 2 to the power n plus 1 plus 5, 3 to the power n plus 1, reciprocal of that. Okay, and that will be limit n goes to infinity. Have 3 to the power n, 3 over, yeah, that will be 1 over 3 times this. This is what? This is 2 times 2 to the power n plus 5 over 2 to the power n plus 5. 1 over 3 can take it outside. Just, yeah, I'm doing it in details. Huh? That will be 2. If I divide by 2 to the power n, in the numerator and denominator, we're getting what? 1 over 3. 1 over 3 outside. That will do nothing. That 2 plus 2 to the power n over 2 to the power n. Yeah, I was saying, I think it's very clear. That will be 1 over 3 times what? This is cancelled. This is cancelled. So you have 2 plus 0 over 1 plus 0. You have 2 over 3 less than 1. That means this series converges. Actually, you can do limit conversion test with 2 over 3, which is a convergent series. Now, part B, I need to find the limit. Yeah, what is an? Let me take it slowly. To n factorial over n factorial, n factorial. What will be L limit n goes to infinity of what? an plus 1 over an. I don't need the absolute value. I'll be careful here. That will be, I take n as n plus 1, so that will be 2n plus 2 factorial over n plus 1 factorial, n plus 1 factorial, reciprocal of that, n factorial over 2n factorial. Yeah, that limit will be what? Limit n goes to infinity of what? Yeah. This, would this give me no need for those. That will give me n plus 1 times n plus 1. Yeah, the same thing this with this. Yeah, but this is what? This is n plus 1 times n factorial. Okay. Now, what about this one? This one, if you notice, it's what? It's 2n factorial times 2n plus 1 times 2n plus 2. So that this is cancelled. So I have what? 2n plus 1 times 2n plus 2. And what will be the answer? I have same degree, so it will be 4 over 1, which is 4 greater than 1. So this series diverge. Okay. Yeah. Using a recursively defined series. You check this series converge or diverge. Okay. So let me do L. L will be limit n goes to infinity, an plus 1 over an. This is recursively defined, so that will make it easy. Limit n goes to infinity of what? Now, an plus 1, this is my an plus 1, so it will be sine n plus 1 over square root of n, an times 1 over an, which is like I'm dividing by, which is now these things cancelled. So I need to check this limit. Yeah. This limit, you can do it. So I have this limit n goes to infinity, absolute value, sine n plus 1 over square root of n. Let's check this limit. Yeah, I think to do this limit, I need sandwich there. Yes, I noticed that sine n is between -1 and 1. So sine n over square root of n is between -1 over square root of n. This is then 1 over square root of n. So limit n goes to infinity of sine n over square root of n goes to equal to 0 by squeezing theorem. Okay, so this limit will be limit n goes to infinity of two things, sine n over square root of n times 1 over square root of n. And this is 0, so I'm getting 0. So that means this series, yeah, that means the series converges absolutely. Yeah, the other test in this section called the root test. What is the root test? And especially well for series involving int powers. If we have int powers, the same idea I have, but my L is different. L will be this, the nth root of the absolute value of an. And if it is less than 1, the series converges absolutely. If it is greater than 1, the series divergent. If it's equal to 1, test fail, test inclusive. Okay. Yeah. As we said before, The test gives no information if it is equal to L. Please note, if L equal 1 in the ratio test, don't try the root test. It will be L equal 1. And don't forget this. Yeah, since you need the power, this is the power. Don't forget this, this limit. Yeah. Let me do this one. What I will do, what will be my L? It will be limit n goes to infinity. The nth root of an. What is an? Yeah, everything is positive, so no need to worry about the absolute value. Now we need to check the nth root of an. That will be e to n over n to the power n, all to the power 1 over n. Yeah, and that give me what? That give me e to, and I'm doing it in too much details, n to the power n, all to the power 1 over n. That give me e square over n. So it will be the limit as n goes to infinity of the nth root of an, since everything is positive. That is will be my L. That will be limit n goes to infinity e square over n, and that what 0. This done 1. So this series converges absolutely. Okay. Don't forget this we did before. Yeah, this one. And we know it converges absolutely. Yeah, that mean both tests should give me the same answer. So let me do what do you call it? The nth root, the root test. So it will be L, the nth root of absolute value of an. Yeah, this absolute value will kill the -1. That will be n cubed over 3 to the power n. And that is what? Don't forget the limit. Yeah, that equal what? Limit n goes to infinity. Absolute value, the -1 will be gone. I have the nth root of n cubed over 3 to the power n. Yeah, this is n goes to infinity of what? The nth root of n cubed over the nth root of 3 to the power n. Change it into powers, I think is better. This one will be what? The nth root of, change it into powers. N to the power 3 over n over 3 to the power n, all to the power 1 over n. This is n cubed to the power 1 over n. Note, this means what? I have the limit as n goes to infinity of the nth root of n, which is what if we take it as a power n to the power 1 over n. That should be 1. Okay. So I think you can figure it out easily, but then I'm doing it in too much details. That will be n to the power 1 over n, all to the power 3 over. So this, as the limit goes to 1, so this will be 1 over 3 less than 1. So the series converges absolutely. Okay. Now let me do this one. What will be the limit? An is this. What will be L, which is the limit as n goes to infinity, the nth root of an, that will be limit n goes to infinity of what? Of the all of this. Yeah, don't forget the absolute value to the power 5 and yeah, I can take it inside to the power 1 over n. Yeah, that will be limit and goes to, you know what? Let me make it easier. I need to be bothered with this minus sign. I can rewrite this as minus 1 to the power 5n times 2n. So absolute value of an will be this, since n is positive. Okay, so now it will be L limit n goes to infinity. The nth root an, absolute value of an, that will be limit n goes to infinity of this. And that will be limit n goes to infinity to n over n plus 1 to the power 5. Take the limit inside, so that will be limit n goes to infinity of 2n over n plus 1 all to the power 5. Same degree, that will be 2 to the power 5, which is 32 greater than 1. So this series diverges. A divergent series. Okay, let me take this. It will be n. N is n factorial all to the power n over n to the power n all square. In other words, this can be written as n factorial all to the power n over n square all to the power n. So it is L. L will be limit n goes to infinity of what? N goes to infinity of the nth root of an. Everything is positive, so I need to bother with the absolute value. Yeah, and this is the nth root of n factorial over n square all to the power n. Yeah, so that will be limit n goes to infinity n factorial over n square. Yeah, and that is what this limit. Yeah, you can't do it this all to the power n all to the power 1 over n, which is this limit. And this limit goes to infinity. Yeah. To see it. Yeah, we can do it this way. That will be limit n goes to infinity of what this n factorial. Actually, it's n minus 2 factorial times n minus 1 times n all over n square. All over n square. So it will be the limit as n goes to infinity of n minus 2 factorial times the limit of n minus 1 times n over n square. That is 1. This is infinity, so that will be plus infinity. So that means this series diverges. Okay. I think this is very clear. I think an. What will be L? Yeah, I'm using limit, correct? Yeah, L will be limit n goes to infinity of the nth root of this. So that will be limit n goes to infinity. The nth root will go with this power, just 2/3 is done. So this series converges absolutely. Yeah. Let me do this, these three, then I think I will. Okay. This one, the first one. Okay. A. What will be an? What will be L limit of everything is positive. An to the power 1/n. Yeah, let me do it as power. I think it will be easier. That will be limit n goes to infinity n square all to the power 1/n over 2 to the power n all to the power 1/n. And that will be what? Limit. Yeah, let me do it here. That will be limit n goes to infinity n 1/n all square over 2. This goes to 1, so will be 1 square over 2, which is half this down. So this series converges absolutely. B, what about with the power n over n cubed? Yeah, I think there's miracle of this, yeah. N will be 2 to the power n over n cubed. What will be L? Will be limit. Everything is positive, so no need to bother with this absolute value. Yeah, I have 2 to the power n all to the power 1 over n. Here I have n cubed all to the power 1 over n. I can use the same trick. When I have 2 over n 1 over n all to the power 3. Notice this means what? Limit n to the power 1 over n. That should equal to 1, which is this one. So I have 2 greater than 1. So this series diverges. The last one, I need to find what is an. It's 1 over 1 plus n all to the power n. So let me find L, limit n goes to infinity. An to the power 1 over n. Yeah, that's very clear. This will kill this. We have 1 over 1 plus n, which is which is 1 over infinity, which is 0, is done 1. So this series converges absolutely. Yeah, 1 over infinity, which is 0. Yeah, let me do this. What will be the nth root of this? What is the nth root of an? Because I need this. Everything is positive, so I need to be bothered. So that will be the nth root of this. And this is the nth root of this. and that will be equal to what? Yeah, this is the nth root of n to the power n over 2. And this is 1 over 2. What is the limit goes to half in both cases? So no need to, yeah, limit. I know that that means this series is between half and this. Yeah, because this is more than 1. For sure, this is more than 1. So, using the limit squeeze theorem, n goes to infinity of half, it will be the same as this, that equal to half. So by squeeze theorem, that will be the limit of this. Will be equal to half by squeeze theorem. That means L, which is the limit, will be equal to half less than 1. So this series will converge. Absolutely. Yeah. Okay. Let me stop. I think we did good numbers of questions. So let me stop the recording, and then I will continue. Thank you.